So once again, we are all welcome to tonight's hands-on training on our Chemoinformatics, for life sciences. So I'm quickly going to share my screen. I hope I am audible, right?
Yes, sir.
Yes, sir. You are.
All right, thank you. So today will be more of hands-on. We shall be doing some little practice. Okay. So if you can see my screen, just let me know.
Yes, sir, I can see.
Oh, very good. Very good. Perfect. So what we have tonight is building local chemoinformatics database from indigenous plants. How we can build, we discussed that yesterday. How we can be able to, although I'm not going to center on plants because we are supposed to have this part yesterday, but the questions and the interactions really took off that time, which is still good. It's always part of the training. Why today we are supposed to be doing how to build models, as stated in our objectives. Well, let's see if we can be able to finish up this on time. Then we shall now look at building our models. But those models, those models, they are minor because they may not really be necessary. If we're unable to look into them, that means we shall look at them at the training coming forth on the 18th, third week of this month, around third week. That is the QSAR and the QSPR. So how do I build database? We discussed yesterday about that we need data. We talked about the need for data storage, our local data. So how do I build my own personal database? Our aim is just the aim of this training is, this training is just a free workshop, just 2 days. So we may not end up building that kind of large database, So, but we'll just see how we can build a local database for ourselves. See how we can build a local database for ourselves. Okay, so now it can be in 2 ways. It can be in 2 ways. Now we are not going to just concentrate on natural products, but we shall also look at synthetic chemicals. Yeah. Now, but then I think before I come back to this, I would like to introduce us to something. I don't know. Have we heard about click-to-drug? Do you know about click-to-drug?
Click what?
Click-to-drug is a site, a depository.
No, sir. I don't think so. Sure.
Okay. Okay, well, I will come to that. I will keep it at the appropriate time. So I will show us that. Now, one look at the basic step-by-step guide. The basic step-by-step guide in building a database. One of the first steps is to select a local medicinal plant. That is, if you are working on a medicinal plant, then you must select a plant you want to work on. Maybe just one plant first. So you can build the database for just one plant first, then later you can increase it to other plants. So we select a local medicinal plant. So maybe I want to build a database for Aspelia africana. That is MOH plant, MOH leaf, Aspelia africana. So I will choose Aspelia africana, and then I'm going to choose, of course, I've thought about the plant, commonly used plant. Then there's some information I'm going to look for Aspelia africana. You check the local name, which depending on your community. So you have to look for the various local name, and then you check the scientific name, which is the Aspelia africana, the part of the plant used, so the several part of the plant that has been used in ethnobotanical reports, and the traditional medicinal uses. So what those parts has been used. So you take note of this. Make sure you have this information. So you make sure you have these informations. Then another step is you search for scientific informations. So I think we're going to start from this point. We search for scientific informations like you look for research articles, theses, or books on the selected plant. So you look for research articles, theses, or books on the selected plant. Now, like I said, I'll be combining both the natural product aspects and the synthetic chemical aspect. So in the synthetic chemical aspect, I noticed that there are no special database for chemical analogs. So there is no special base for chemical analogs. That means you can decide, instead of you choosing a plant now, you can now choose an analog you want to work on. A particular analog you may wish to work on. So if you choose that analog, then you begin to look for research work that has been done on those analogs, their derivatives, and their biological activity that has been carried out. So most importantly, these are what you look out for. But I think we need to continue. I just want to streamline the class. Let's work on this chemical database first before we come back to the natural products database. Okay. So let's look out for analogs. So I'll come back to this natural product database, which we might be using any plant, maybe Aspelia africana, Peperomia pellicida, or any indigenous plant of your choice. But I will begin with the synthetic chemical database. So even if I'm going to work on those synthetic chemical database, I will still need articles, journals, theses, or books that is talking about those derivatives I want to work on. Then I'm going to check the analogs of that compound. Maybe I want to work on anthraquinone, want to develop database for different class of compounds. So want to get their analog. Just the same way you are going to identify the phytochemicals for the plant. Now the compound is now representing our phytochemical. So it's now representing our plant, while the phytochemicals from natural products is also representing the derivatives of that compound. So you can source for them, just the way you source for phytochemicals using a GCMS reported work to source for those phytochemicals. That means you're going to search for your plant a lot of GCMS report that has been done. Okay, so we may not be looking at other database now, because most times you can get information from this other database, but you can just create your own by looking at for a lot of GCMS characterization, UCLMS, LCMS, HPLC work that has been done on that plant. And the same way too, you will look for analogs of that compound that has been generated. That is for synthetic database. Then the next step you will do is to record those your compound details. So those compound you have gotten from your plant, you have to record them. Even the compounds you have gotten from the analogs you have also gotten from your compound, you also have to record them. You have to record the compound name, you have to record the molecular formula, you have to record the source. Yes, very important for validation. You have to record the source, the journal where you took those work from. Yeah, you have to record mostly. You have to indicate their DOI so that it can be very easy to click on the DOI, and once you click on the DOI, you can now go back to the work itself. You can go back to the work itself. Then you have to record the activity. Now, for our natural products, this aspect might be a problem to us. Yes, these aspects of the biological activities of those natural products might be a challenge to us, because while you are mining those GCMS, most times biological activities of individual natural products are not really reported, but what they report is the biological activity of the plant extract itself. So except people who have isolated those individual bioactive compounds, who have done the isolates and then used the pure isolate to conduct some in vivo or in vitro studies, that is the only way you can get the biological activity. But the biological activity of some of these derivatives, you can easily get them because they are available online. You can easily get them. The next step is obtain their chemical structure. So you're going to obtain their chemical structure now. We're just getting the overviews of requirements for building a mini database. So you obtain their chemical structures. You can search for each compound in some chemical database. So you can download their structures from some of these chemical databases, or you copy. So you copy the compound. You go to some drawing tools like ChemDraw. You copy the name, and you do the structure. You model the structure. That was the essence of the last class we had on the beginner's course on computational chemistry last week. So you can now model these compounds in 3D, because this database you want to build, we have 3D structures of your compound. Then you can now generate their smiles. If you include their smiles, you include their each key, their SDF file, of course. Then the next step is you draw and verify structure. This step can be overlooked. Here is those structure you downloaded from those PubChem. For you to use a structure you downloaded from other database, you have to verify the structure if it's correct with the name of the compound before you go ahead with the one you downloaded from those database. Because most times these people who upload these compounds in database there might be mistake. Yeah, there's a room for that. Yeah, there might be a mistake. So you have to verify the structure on your own by you redraw each compound using chemical drawing software. You check the atom types, bonds, and the stereochemistry if it aligns with what you downloaded from those databases. You save the structures in standard format. So this is to verify the structure. Another key part now is you create your own essay work structure. So you can create your own essay work structure, and we shall now come to creating this essay work structure after when you have generated all this data. So when you have generated all this data, then you can now create your own Excel worksheet. And then you will need data on their physiochemicals, on their physiochemical properties. Yeah, so you need those data also. So quickly, let's start with getting the informations that we need. As we have just explained, the information that we need, then we'll see how we can use Excel to build a little Excel workbook. So, but these are the step by step, a few step by step. Then we shall look at how we use Excel to build a little database for yourself. So I will start with chemical database. I will start with chemical database. Now, if I want to do a chemical database, I want to do a work on chemical database. So let's say I want to do you can focus on a novel chemical database that maybe you think people have not focused on that aspect. Unique, just unique. You know, PubChem is really, really universal, but it can make yours unique so that whenever people are looking for natural chemical database of analogs, yeah, a class of compounds and their derivatives. So they will easily focus on that your database. So class of compounds and their derivatives. Yeah, class of compounds and their derivatives. And then you are stating their biological activity. So let's say want to work on okay. I'm looking for a way I can really do that. Or we can develop also. Okay, let us try. Let us see any derivatives. Which derivative can we use now? Which compound can we use? Do you have anyone in mind that we can just use and see how we can create a database for that compounds and their derivatives, including their biological activities? Let's say indole. Let's try indole. So what you just need to do is to type synthesis and in vitro synthesis, comma, in vitro and in vivo activities of indole derivatives. So we just see. So we want to build a database of indole derivatives. So we want to build that the database for indole derivatives for derivatives. So you can have indole, you can have quinine, just like that. So, but whatever we do to indole now, you can do that to other database. So we're going to look for journals. We're going to look for research articles that has to do with the derivatives of indole and their activities. So here is here. Can you see my screen?
Yes, sir. They keep
Okay.
paying us on the internet. So.
Yeah.
No, we can't see it.
Can anyone see it?
Yes, we
But
can
I
see.
can now. I can now.
Okay. So in this in this
We can't see it too.
uh please, if your mic is on, kindly mute your mic. So if you want to build this kind of database, you just require some carefulness. Now, the only challenge is that if you look at this work now, they have the derivatives C1 to C5, and then here you can look at the antibacterial result of those C1 to C5. But we appreciate when you get their value in IC50. So even the C1 to C5, their name were not mentioned, except we scroll up. Okay, we have their names. So here we can find 5 derivatives that we are modeled from indole. So here we have derivative 1. Derivative 1 is 2,4,1,2,4,1,3 amino phenyl. Like this is the derivative 1. So it means that we are going to get this compound now, and this compound from C1 to C5. So for this journal, we're able to get some information that we need. We need informations here. Primarily, we need information of those compounds, their names, and their biological activity. Then we shall now use the name of the compound to develop the smart code, which we shall use to generate their physiochemical properties from other database. So that will be very simple. That will be very simple. So for this one now, I will keep this aside. So you have to look for as much as possible. You have to look for as much as possible. So you keep opening as much as you can. You can use a Google Scholar also to help you in this search. You begin to use other search engines for Indo derivatives. So do so much work here. So there is so much work to be done here. I will just download as few as I can and see the ones that are relevant. So this is like when you are doing a systematic review. So you also search this work. This is a phytochemical macromolecular intervention of Indo and their derivatives. So you can scroll down also to see if it has what we need. We need the biological activity of those compounds. Of course, we need their structure. So here, this journal did not stated their biological activity. So it's just a review that was done. Okay. Where is the download? Okay. Now another one. Okay, if you can find the download. Okay, full article not possible to download. Okay, this is design, synthesis, and biological evaluation of some novel Indo derivatives. So let's see if they did their biological activity. Most interest is on their biological activity. Okay, so this is the work they did here. 13A, 13B, 13C, against +2, against +1. So we'll be taking this their record. We'll be taking this their record. So quickly, you can open up your Excel sheet. You can just open up a new Excel sheet, since we want to build we just build a simple one. So you can open up a new Excel sheet. So you type here derivatives. So this could be our derivatives. These are derivatives. Then we have the activities that has been recorded. So all this will form different activities that has been recorded for those derivatives. So what we'll just do is to copy those derivatives and put them here. So I'm going to make my Excel sheet. Now the essence of this is you can easily come to this place and extract basic information without you without stressing yourself looking for other database. And if you look at this now, you hardly find database of this kind, these Indo derivatives and their molecular activity. So it will take you a whole lot of time to create this database. Just do something small. It's just for you to do something small. So I'm going to share my screen to be like this, so it will be easier for me. So let me open another one. This is a review. It does not account for an experimental work. So this one is for a review. It does not account for any experimental work. Okay. Let's just keep seeing what they have. So this is design, synthesis, and antifungal activity of Indo derivatives. So if you look at it, you check the results. Okay, so they have results, and they have the EC50, which is very important to us. So from E1 to down to E1 to E21. So we are going to look for what those E are. Look for what those E are, what they stand for. I think let's just start with the little we have now. Then you can beef it up as time goes on by searching for other journals. So if I'm to start with this first one, so first of all, I need the derivatives. I need their molar weight. I need informations. Okay. I need their molecular formula. I'll need information on their molar weight. I will need the information on their structure. Very important. So we can just have a 3D structure here. Then I will need informations. Okay, this informations is what I need for from the literatures I'm going to download. Then why others will form their biological activity. Yeah, this will be stressful now, but that is how you form a database. So you can come to this one first. The C1 is this compound. See how you can copy the name of the compound. You paste here as your C1. We can equally look at how we can test wrap this. Yes, so you can test wrap it. So I can test wrap it. Oh, it's not responding. Okay, fine. All right. So I can shift a bit so I can give them my code, my index. So I can give it index. So I can give it, let me just go back. I'm coming. So I just have to adjust a bit so that my first column will be my index. My index. So I can say Anna 001 or in ND 001 because I'm for Indo. So let me keep it as test wrap. Okay. So on these notes, as we have done, we will need, so we have copied number 1. You come to number 2 from this journal. You copy number 2 from this journal also. You paste it here. So I will just do the test wrap later. You locate number 3. Locate number 3. So these are derivatives of Indo. Locate number 4 according to them. You paste your number 4. You locate your number 5. You copy and you paste the number 5. So the next thing now is to get their biological activities. So you can later, you just put all data here, but later you can split it, but we are just putting all data here. Then we are going to that. So these are from C1 to C5. This is their molecular formula and their molar weight. So for now, what I will just need to do, I will just need to highlight this and do my test wrap first. So this is my test wrap. That means
I think I lost the screen. It's not showing.
is someone see my screen?
Yes, sir.
You copy the molecular formula.
No.
Paste the formula. You copy the molecular formula. You know, this whole process will seem stressful. Is anyone see my screen?
No, we can't see it. It's not visible.
No, we can't see it.
I'm seeing my screen.
I can see your screen.
Yeah. So you see how this is time consuming. That is what you do. Just building. This is all small. You copy all this. You paste. So imagine those database you are enjoying. It cannot be done by one person. So you need as much as data, as much literature, as much literature. But the question now is, what if there is no literature available?
Please, sorry, please. We can't see the screen, please.
Can anyone see the screen? Because some persons are complaining of not seeing the screen.
Well, I can see it. It's just due to their network. The network tonight is terrible. It's very bad.
Okay. Okay. So, sorry. This whole process might seem really, sorry, really slow, but that is what it should be. So I have this index. You can do that automatic. There's a function you can usually use to do that index instead of coming manually, but we'll leave that. Now I have for this derivative, for this compound, I have this. Then I'll look for the activity. So this is what I need first from my literature. My literature, this is what I need. You may not even need the molar weight from literature because we can generate all that from other database. Now the next thing we need is their activity. So this one is antibacterial against E. coli and Aspergillus niger. So you have to indicate the activity. So this is against E. coli. And normally we are supposed to use activities at we are supposed to use journals that expressed activity in IC50. So this job, it was not properly done. This journal is not well done. They are supposed to express.
Can't we convert this microgram to IC50?
No. It's not in concentration. IC50 is not a concentration. The IC50 is we can convert their zone of inhibition, but they just did 100 microgram to 50 microgram. So assuming they had let's say 25 microgram, 50, maybe 100, 150, 200, 250, up to 5 different concentration. And then we have their inhibition too. We have the inhibitions. So we can use simple Excel to plot a graph of their the log of the concentration. Those their concentration. You have to find the log of that concentration, and then you plot a graph of log of the concentration against zone of inhibition. So when you plot that graph, it will be an exponential graph. It will be an exponential graph. So when you plot that graph, you can now generate the equation of the graph, which will appear in y equal to ms plus c. So from that equation of the graph, you are going to now extrapolate. So you now calculate what will be the concentration from that graph. You estimate for the concentration at 50% inhibition, because you have already plotted the graph of log of concentrations against a zone of inhibition. Then when you have that value, you have your y, which is the log of concentration, equal to your m is now the slope of the graph. The s is the zone of inhibition which you plotted against, plus c. The c will be your intercept. So when you generate this equation of best fit, this regression equation, you have the value of your slope and the value of your intercept. So we have done that. You can now you can now say, yes, if I want my S, which is 50%, what would be my log of concentration? You can now calculate the log of concentration from the regression equation. So after calculating the log of after finding the log of concentration, you can then turn back that log of concentration to concentration. So that prompt you have now is now the concentration in microgram per mil at 50%. That is the IC50. So assuming we have a series of concentrations, we would have plotted the graph to generate the IC50. So that simply means that we may have wasted our time here, but I'll take this pending. So I'll carefully look out for journals that reported IC50. Yeah. Now, but I wouldn't advise you pick. These are mere zone of inhibition is not biological activity. The best way to express biological activity is always in IC50 if you are inhibiting, or EC50 if you are activating, then LD50 for the toxicity. So we can equally go again. This is what you keep doing. Okay, now I have this, and I'm able to see this one now. I'm able to see the zone of inhibition. It has calculated at IC50 for cross 1 and cross 2. So you just need to look for what is 13A. So we have from 13A to 13F for table 1. While for table 2, okay, table 2 does not have business with, okay, table 2 has ED50, which is the activity also, ED50, still 13A to 13F. So we are after the IC50, 13A to 13F. So look for the 13A to 13F. You just have to scroll up. It will be stressful now if their names were not provided. Oh, so in this paper, their names were not provided. So what you just have to do, okay, I can see that. So 13A, all right. So you copy 13A as well. This 13A, you can come down below. Okay, no. That is not 13A. This is my 13A. So we have just we wasted a little time. So I'm just copying these first, their names. So if we're able to do this, I'm telling you that you just end up having a unique database. You end up having a unique database that's, and the reason why I do say that it is unique is, can you hear me? Hope you can still hear me.
Yes, I can hear you. Yes.
Yeah.
Yes, we
Why I
can
do
hear
say,
you.
yeah, why I do say that they are unique is, you will notice as we proceed that some of these analogs now that we have synthesized, if you take their names to some chemical database, they will tell you not found. Yeah. Even I don't know if you that join us in these modeling classes, the modeling, those compounds you modeled, if you take some of them, their names to PubChem will tell you no record because it has not been deposited there. It has not been deposited there. So what we need now is, this report does not provide their chemical formula or their molar weight. So we're going to get that by ourselves. So we'll skip this molecular formula, we'll skip the molar weight, we'll skip this structure. So we'll come down to cost 1 and cost 2. That is the activity that was done against cost 1 and against cost 2. So what they are finding, so we are picking the IC50. So for this first one, so you see we are doing that manually. Somebody will say, why can't AI do this for us? Right? Because we like sharp 8.5, 0.24. So I really like this result. 6.7, 0.53, 9.2, 0.18, 10.1, 0.19, 7.1, 0.48. All right. So this is this is indomethacin. I will still include the indomethacin because it's still a reference indo derivative. So I will include the indomethacin. 0.039, 0.49. So we're able to get the what I will do, I will keep this. Oh, I was writing on that structure. So let me see how I can keep a column for smile code. So let me see I can keep a column for smile code. So this is cost 2. Why this is cost 1? Then this is their structure. I'll keep this column for smiles. Right. So maybe I will just concentrate on just this one now and develop the full database for just this one. We have their activity. So if you're able to get other compounds too, you keep adding the activity up. You keep indicating the activity. So if you see other activities, you keep indicating the activity. So the one that does not have that activity, you put dash. You put dash on those derivatives does not have the activity. So you be careful to see if there is a repetition of derivative. If there is if derivatives were repeated, of course we can know when we are doing sorting, because we have to sort it, so we know if there is a repetition of a derivative, so we can merge the activities together. So let me look for another journal, so that it can be comprehensive. Okay, I look at this study. They did the Indo derivatives are cycloogenase inhibitors. I think that is the one we just leverage on now. Okay, this is Indo derivatives are cycloogenase inhibitors. You scroll down, S1 to S18. Okay, here the activity was not represented in IC50, so you also have to leave it. Let me see if it was an IC50. No, so it was not an IC50. You have to leave it. So you see challenges we are having in trying to create a database. So you scroll down a bit. Let's just keep seeing if we can find activities in IC50. Okay. I don't think if these people did kept the activity, if not, this work would have been a very good job, because they did a lot of activity here, but their values were not kept at IC50. So they did a lot of work in this paper. So I have to leave it. So you just have to leave it, and let's see another one. Respiratory importance of Indo nucleus in recent years. So this is a review. I can try academia.com, academia.eng. So we can also leverage on Google Scholar also. But if I could not find much more journal, that means I will just have to continue with the little we have gotten. So let me say here, I can search for synthesis of Indo derivatives. Just synthesis of Indo derivatives. You may probably get some work here. So let me say synthesis and in vitro studies of Indo derivatives. Synthesis spectra. Okay, so this is a work. So Indo derivative are circularly in between activity docking studies. So I think we don't think if I have this.
Hello, sir.
Yeah.
Sir, can you try Campbell database to download the inhibitors with non-concentration against the OX180.
To try which database?
Campbell database.
Yes, but we don't want to start using other database first. So you have to create. The idea is creating our own using literatures first. So using literatures first before. If you are creating your own with by copying what is in another database, you're just copying exactly. Although there is a room to relate your findings with other database. But there are much work here. I can really find much work here. There are really much work here in the database. Okay, so let me do with what I have already. So you can find much here. Let me work with what I have already now downloaded. So this simply entails that you'll be ready to download Jonas. You download Jonas. Download Jonas as much as you can. And please, there's a room for reference. So I forgot to also keep that. You are going to reference that Jonah where you took that work from. So let me quickly do that. I have to reference that Jonah. So reference, I can keep it here for easy access. So that means I have to go back and look out for the Jonah I used previously. So check for the DOI. So just see how. Oh, just looking for how I can copy this DOI. Okay. Okay. The DOI is really proving can't really copy it, but if I take this source, if I take this source, it will still represent that work. Let me see. All right, so good. I can take this source since the DOI is difficult to copy, so I can paste it here. So I can paste the source here. So going back to this other one. So now at this, okay, no, this one was not for this. It was for this compound. Sorry. All right. So it was for this compound. So we will not end up making mistakes. All right. Now, you search, you check this journal now, this new journal. You also scroll down. see what was reported. Just come down to their results. Oh, there was no IC50 here. So see, these are challenges now we are seeing in creating database. But they actually did a graph of the percentage inhibition against concentration. But I think that is just normal for antioxidant graph. So this journal, so this is to tell us the kind of work we are doing now. You can see the kind of work we have. Some reports that could not stand the test of time in trying to create database. So I have seen this before. So let me try this. All right, so this is giving me IC50. So I want to encourage all of us who have interest in vitro analysis. Please always keep your final inhibitions or effective values at IC50. It helps. It helps. So I'll look out for this table is for anti-proliferate. So these are different cell lines, cancer cell lines. So I shall take these cancer cell lines and also take their inhibitions. So let's look out for what are 5A and 5B. Let's copy them. So this is what you keep doing. That means this thing that we did now, you will come back to your Excel. You will come back to Excel. So I just have to delete this first one without IC50. So I have to delete them. Okay. So what we are just doing now is that we are getting another journal, and you keep doing the same thing. You keep doing the same thing. Once you get another journal, you include their names. You include their names. So once you get another journal, you include their names. Okay, this is not part of our compound. So you join with the one we have already. So you come below, join with what you have, then come top here, killing those activity. Like in this case now, we are having another set of activity, which are the cancer cell lines. So here we're having another set of activity, which are these cancer cell lines. So copy these cancer cell lines too, and indicate here at the top. Indicate here. Copy these ones to indicate. Copy this one to indicate here. So now you notice that for this first compounds now, for this first compound we have added here, there will be dash for cancer cell lines. But for our other compound, we'll now include their cancer cell line values. So go up and look for what is 5A. Check what 5A represents from their synthesis results, from their synthetic results. If there is, you check for what 5A represents. So once you open a journal, your first point is to see if it has inhibitions, if it has activities at IC50. So still one question available to survive. Okay, I needed to see their results. The result of 5A, 5B. Okay, fine. Look at it down. So this is the 5A. So this is 5A. You copy this. You come under this one, under the ones you have done. You paste. You look out for 5B. You copy. You paste. So after this journal, after this one, I will now proceed to the other step. Look out for 5C. Look for 5C. Copy 5C. You paste. Then you check 5. So this is just for Indo. When you are done creating everything for Indo, you enter another database. Maybe you can use another sheet 2 for another scaffold. So I've done the 5 to E. So I can just do my test fab. Then I'll look for the activity. So I will have dash for this cos1 and cos2. I will start from these 3 activities, which are the tensor cell lines. So let's go back to their tensor cell lines. Let's go back to their tensor cell lines. So begin to copy less than 0.01 for this. And this is for this. So this is what you will sit down and be doing. This is what you sit down and just be doing, because you need a database of synthetic chemicals and their biological activity. So you can call this database any name. You can call it, you can just form an acronym for it, but mostly we are focusing on database of synthetic chemicals and their biological activity. Then give it an acronym. So that whenever people search for those derivatives, for any derivative, they could find them and their biological activity, or with other details which we can now generate through other database. Okay, there is no inhibition at all for this. So I have this. I have to also reference this material. Very important. So I'll look for their DOI. Okay, so this is that. I have to copy this DOI and paste for these ones now. So I have to paste them for these ones. I can drag it down because this GUI covers for all of them. Why this one covers for all of this? Okay, so at least I have these two can be okay for me. These two can be very much okay for me to start with. So I just use two journal for now. So for this, I will say dash. I will call it dash. I will give it dash because they were not found. Okay. Okay, let me give it null. Null. So not found. So I can take it down. And the same thing here, I will say null. I will also take it down. All right. So far, I have these two. I have these two datas. I have these two datas here with me. So I would need to now generate I think one of the results. I didn't copy one of the results. 1, 2, 3, 4, 5. I think I did not finish up the results.
There was no activity for that one now. That last one.
Okay.
Cassette.
I need to, yes. Sorry. Sorry for that. So let me just remove it. Okay. So now the basics has been generated. Another thing, so if you keep doing this, then keep expanding you keep expanding the activity. Keep expanding the activity. Keep expanding the activities. So we can sort to see if there is replication, if there is duplicate. So we can merge the result of those duplicates. So if we're able to see duplicate, we can merge the result of those duplicates to become one. So you just go to data, go to sort, and we are sorting the derivatives from A to Z. So let's see. So definitely, so we just did this, but we know that there is no repetition, but we have large different journal. Some of the compound that these people synthesized might also be synthesized in the other compound. So when you do this, from the name, you can tell. From the name, you can tell. Or whenever you want to remove duplicates, you come to this place to know if there is duplicates. This under data, remove duplicates. You can select, just select your derivatives and see if there is duplicates. So it will tell you no duplicate values found. So if there is duplicate, you may know. But once there is duplicate and you are going to remove duplicate, it will remove the duplicate. So how do we now generate their molecular formula, their molecular weight and SMILE code? So for their SMILE code now, let's go for their SMILE code. We'll now go to other database. So let's look at PubChem now. Let's look at PubChem. So we can use PubChem to generate their SMILE codes. So I copy this and I paste in PubChem. Now, what are you seeing in PubChem now?
Nothing found. Nothing found.
Yeah. Congratulations. So the journey just started. I checked another one. Nothing found. So you keep checking. Because I told us earlier that most times why this aspect of the database is still novel, because some of the databases have not really recognized them because they are still new. They were compounds that we have synthesized. So here we're able to get this one. That is this one. So you can make use of this and get their molar formula, the molecular formula. You get the molecular weight. Then you get the SMILE code. All right. So that's a good one. So you come back to this one. Paste in your PubChem. You say nothing found. You take this. You paste in PubChem. Nothing found. Most times, this nothing found, you can check the structure, the IOPAT name, if it was well written. Because if not well written, you will see nothing found. Nothing found. I know most of us would like to try this. Now, what will be the remedy for the ones not found? You can try other database also. Let's see, KBL. So before you conclude not found, it means you have tried other database as well before you can conclude not found. Well, I think PubChem is really is enriched. So whatever you could not find in PubChem, just know that you may not really get it anywhere. So let me search with the name. So KBL is searching. You must be careful of the results you got from KBL. Look at the result. I don't think if this is that, because it gave me a different name entirely. So this is not what we're looking for. So you must be careful. So this Cambria just gave me names that has the common names with what we are searching, not the exact names. So you can check for compounds instead of assay. Let me check compound. You see 7.1 thousand compounds for just this one compound. So who can suggest what will be our remedy now? If since these compounds happens not to be found in this already created database, what will be our remedy?
I think we can go to ChemDraw to generate these other parameters.
All right. So you can quickly copy to ChemDraw. Then I would now tell you the ugly part you would like to hear. Let's go to ChemDraw. So for those who have it was his opinion that is taking me to ChemDraw, not that we intend using ChemDraw for this training. So go to ChemDraw. So in ChemDraw, we'll now do converting name to structure or searching for them. So this is just giving you the ideology that it is not easy to create a database. It is not easy to create a database, but you can do that. You can do that because these were the pains. These are the pains that people swallow just to make sure they create this database for us. So let me paste this name. So okay. All right. So now ChemDraw has been able to give us the structure of that name, and you see the essence of their previous training. So what I will now do now is to go to view chemical properties, or I can just take a chemical analysis window. Okay, let me take the analysis window, view chemical analysis window. Today's training has been so quiet because it's not that kind of training we shout and we jump up and down. So yeah.
So many of us are lost, including myself, and nobody is finding me. But the Lord will find me somehow.
Okay, let me just paste it below it so that I can easily take it from there. So for the formula, so let me take it. I copy the formula. Then the exact mass, okay, that is the molecular weight.
The molecular weight.
Yes, molecular weight. So then we generate the smiles also. So I will come back, click. So imagine you have 100 compounds. You have 100 compounds of indole. Imagine you have 100 indole compounds. Edit, copy as smiles. copy the smiles. I then come to this place and I paste the smiles. So this has been done. We will not come back to this structure. So for the structure, you can take the 2D structure. You can take this 2D structure first. But while you are doing that, you are going to mostly use the 3D structure. So I'll paste my 2D structure here. So I'll just put the structure here. Let me test swap this. Let me test swap this. All right. So this is what we are expecting from you. You come back to this one. You copy. You go again. It's really interesting, and I'm enjoying it. It's really interesting, and I'm enjoying every bit of it. So some of us will be lost because we never intend coming to this point, this part, because we so I copy this.
Well,
So I'll just
Kendra,
do
what do you intend using before?
all my hope was we can get our data from literatures just for them. If not, I would have made access to ChemDraw, and making access to ChemDraw now, meaning that the participants, we have to have a basic knowledge of ChemDraw, which I know that not all the participants here have that basic knowledge.
I think we need the ChemDraw first. Later we can now learn it. Because if you don't have it, you can never learn it.
That is true. We had a training last week that we focused on ChemDraw. So I don't know if no. What I'm about to say, we don't do it, so I'll just keep it back to me.
No, how can we get the ChemDraw? That's the first point.
Even if we give you this ChemDraw now, you may not be able to use it. Yes, you may not be able to use it because you have to be trained on how to use the ChemDraw. But some of you we are privileged to be in our Chem test class.
Yeah, exactly, sir.
So you can try. You can try if Chem stage does not have that platform of generating
Large
yes. No,
extensions
not even large. Chem stage cannot convert name to structure. Only convert name. Yeah. So we are putting up a training. We are putting up a training on this by April. So by April, we have a detailed training on building database. By April, we have a detailed training on building the database. That will be a 1 month training. So in that 1 month training by April is strictly on building. So we'll give you all the necessary tools you need to build database, because you need a lot of tools. You need a lot of tools, too many tools to build an efficient database. So next month is March. I think the monthly training we have for March should be macro 4 design and modeling. That's what we have for the month of March. So for the month of April, our monthly training is on this aspect we are doing now, which is building a personalized database. Is by March, by April. So just don't be in haste. If God keeps us alive till April, you have access to not only ChemDraw, to other tools that will be needed for building a personalized database. So you have access to all of them. So the chemical analysis window. Right. So after now, you just give me 2 minutes. Let me come in. So the journey is not easy. Yeah, the journey is not easy. So you can imagine, how do PubChem benefit from this free database, free access? I'm not sure if I build my own, I'll make it free. Except it will be sponsored by the government. If not, people like us, we have to pay. And you have to pay in dollars.
It's easier.
Okay, now just put yourself under this stress now. Do you know how I'm suffering here? You are doing this. If I give you don't worry. If I ask you to do this now, you will tell me
But you say you are enjoying it now.
Yeah, it's true that you say you are having fun.
and enjoy which form? Somebody enjoy suffering. Do you like suffering? Well, that is somebody will ask me now, can't I do this thing for us? Oh, nobody wants to ask that question.
No, no comment.
I think I'm tired at this point. So just give me a minute, I'll be back. Yeah. Okay. Thank you so much for that little time. So you see how stressful it is. We are just doing just few derivatives. So I hope we can still get participants who will do their mini project on this area.
No, no, sir.
Hey, who knows? The
If
truth
let's
is
say
that
this,
I know you want to say 1,000 derivatives now because
am I mad? Am I mad?
Don't even have to do it. That because to start doing it.
Don't I have conscience?
the truth, I'm actually lost, but I believe I'll be found if I go to maybe the video again. But I
Yes,
understand
yes.
exactly what you're doing, but I got lost from the step-by-step process. I understand everything, like all the COX, the cancer cell lines, and the various inhibitors, but anything in between how they were gotten is where I'm lost.
Okay,
That's
God will
my
help
only
you.
problem. Amen.
So what we have just done now is what we'll continue doing for others. This is just for the sake of the training. So you know what we did. The limitation some of you will have now is access to ChemDraw to be able to generate some of this data. Then the other information we need now is the physiochemical parameters. So that would come. So we can give this in three categories. So I just want to generate three categories of my data. I can call this. I can call this merge this stop and call it chemical identities. Or I can call it chemical. Let me just call it chemical identities. Then, of course, this remains as my reference. Then, depending on where you stopped in your biological activity, I can merge this and call it my biological activities. In brackets, remember IC50. Okay. So this remains as my reference. Then I would then generate their, okay, I think, then I would then use this, their smile code now. I will use this smile code. Okay, let me just complete this last one. Let me just get the structure of the last one. So let me just get the structure so it will balance up at least. Let it be that we did complete. So I really want to appreciate you for this time. In the eastern part of the world, they say Odivizi. Yes.
At all.
Yes. They will say Odivizi. So it is not easy. It is not easy. So we still have a lot of trainings like this, difficult ones, more difficult training. So I'm just putting this just for the 2D, but if you are taking it to publishable, then you have to. But what I do, like what we have done in our own part, is that we keep their 3D structures in Dodo Drive, and then we take the Dodo Drive code, the link. That is what will be on that structure, so that once you click on that Dodo Drive link, you can go back straight to the structure and download. That is what we'll do. But coming to do that now is another job on its own. Just building a local for yourself. It is when you have them built like this, then you can now ask for the service of a web developer to make them reasonable. So lastly, what we'll now do is their chemical descriptors, or better, their physiochemical properties. So this is where we leverage on either AdMed or on Swiss AdMed.
Swiss.
So let me just use Swiss. I can use Swiss. So I'll copy the smile code now, because what I need now is smile code. So I copy the smile code and I will go to Swiss. I'll go to Swiss. So this is Swiss AdMed. When you get the video, it will be helpful very much. When you get the video, you just have to follow through what we are doing step by step, and you really get what we are doing. You paste the smile codes and then click on run. So we can just, all this will not form, we are just picking their physiochemical properties. Already there is formula weight here, there is molar weight, but I will just focus on this from this part, so I can use this to form my own. I don't want to start having much, because my own database now is focusing on their biological activity. So, and if you look at this Swiss now, Swiss AdMed, it does not have business with biological activity. So I won't start, I will not start making my own database as robust as Swiss AdMed or AdMed Lab, because those ones does not have information on the biological activity. So my database is focusing strictly on biological activity. So that is why you have to rely on literatures very much. PubChem, like Salisu was saying, PubChem can help you. And I will show you that how you can also get biological activities from PubChem to add up to your work as Indo derivatives. So that is why this man is done loading 4. So you can save this. You can save this result as CSV. Download as CSV, that is SFI. So once it downloads, I can open it. I can open it. Then you can leverage on PubChem. You can leverage on PubChem also. So what I will just do is I will copy. It's already well arranged according to how I pasted. How do I pasted? Like number 1, number 2, number 3, number 4. So I have molar weight. I have molecular formula. I will just have to take from here. Remember, I want to stop at the physiochemical. So I just stop here. I will add it to my database as the physiochemical parameter. So that will come here. From here now. What did I copy? All right. So I will call this histochemical. I will call this histochemical so that histochemical data. So to avoid someone knowing that we copy it from this, let me move this hash this, hash that. So you have to just so all right, that is a wonderful job. So I just built my just try to use what we have and give you little theme. So this is a simple database just for Indo. So just for Indo, if you can build this to up to like how many? Up to, you know, databases. At least if you can achieve 100. So you can say, okay, I'm picking 200 scaffolds or 1,000 scaffold. You know, the scaffold might be so large. So like Indo, Pinon, Pinin, Entrepreneur, just get as much scaffolds as possible. Then your sheet one, I can call it Indo. I will name to be Indo. Then it goes over to sheet two. You can do the same thing you have done for sheet two. You can call it Quinon and work for Quinon. So by the time you have achieved up to 2,000 derivatives or 1,000 derivatives or 200 derivatives, at least just something, but not something so empty. So then I have to reference. You see this data that we collected from Swiss admin. You have to reference that these ones we are from Swiss admin. So I don't know how we're going to attach that aspect for now. I think I have to create a room.
We'll put it at the bottom of the table.
Okay, at the bottom.
Like a note.
Okay, a note that physical data we are from Swiss admin. That is if it solely dependent on the Swiss admin. Case, I would have wanted to still keep it beside as part of the column. Like I would have made this reference. You know, this my biological activity. That is this reference we have for the biological activity. So I would have equally made this reference to be part of my biological activity because these are the reference for biological activity. So I need to also get the reference for this. So I just put it here. For me, I'll prefer putting it here so that they will know. I can just prefer putting it here. So Swiss admin, you get the link. You get the link of Swiss admin and include it here or for all. Because most times you may not want to use Swiss admin. You may say to use another maybe admin lab. You also reference the admin lab alongside. So they will easily know that your biological data we are gotten from this part, why your chemical data we are from this other journal.
I have a question.
All right. Yeah, you can go ahead.
Yes, sir. We got some of this data from journals, from manuscripts. And let's say that while building our database, we got some LC 50 values, that are high. High LC50 values means that the substance is not toxic. When the values are really high, generally LC50 values that are high means that the substance is not really toxic. If we now check with ADME, if we now check the ADME properties from maybe something like Swiss ADME, and it's saying that it's very toxic according to them, what are we going to do when we have conflicting results like that?
Okay, I would throw back that question to the participants to react. Yes, let us interact with that. Then I will do my conclusion.
Hello, sir.
But then,
Can I chip in?
okay, before you reply, she's saying that our lab reports, because we believe that those literatures are lab reports, because those compounds were synthesized, and then they did the laboratory work with those compounds, and they got that LC50, that is their latter concentration, from literature shows high, and from database, Professor Adola, which of these database does suicide med give anything on biological activity?
Sorry, come again, please. I don't understand.
Does Swiss admin report any biological activity?
Yeah, molecular activity, maybe. Since admin, the times I looked at it, I was just looking at the toxicity values.
Okay. Probably, maybe it's found in ADMET, or Swiss. Maybe it's found in ADMET. So I believe ADMET should have LC. Yes, ADMET had LC50 for environmental bioaccumulation. So she's saying, how do we handle this data now that the literature work, which is to us is the lab work, is contradicting to what we got from the other chemical database? What do we do at that point?
Okay, so I think we should rely on the literature works because it is experimental. While in the use of Adamet Lab or Swiss Academy and other stuff, they are predicted values because they use deep learning or machine learning to predict the Adamet properties.
Okay. Yes, to me, that is what I will do. Yeah. Do you have another response to that? Do you have another reaction to that? Yes, to me now, that is what I will literally do. But I'm always afraid. I don't know what gives me this fear on literatures. I don't know, but is it because I'm not a fan of publication of paper, but I'm always afraid of publications, like what we see as publications. Help me to rely on it. Give me a reason to rely on publications. Give me some reason why I should. Are they really authentic? The data they are presenting, is it really what they got in the lab?
Okay, so I think we should only look at the literature data and see if the data is reproducible. But if it is not reproducible, then it is not reliable. I hope I'm making a sense.
That means you go to the lab yourself. Is that what you're saying? You go to the lab yourself to check it out.
Yeah,
But,
I think that
but we are supposed to rely on paper. But my point, just look at, well, I have no choice than to rely on paper, but just that I'm afraid.
No, but if the paper is from reputable journals, I think we can rely on it 100%. Reputable journals. Q1.
There's something that comes to my mind.
Okay.
Yeah, it's not only Swiss Admet that we have. We also
Yeah.
have Admet Lab and maybe others. So maybe we should just check it with other online.
In fact, yes, Prof, I said I would do something. I said I will show you click to draw, right? So your this thing you said now. So this is, I discovered this while I was doing my personal training. Can you see my screen?
Yes.
How many of you have come across this site before?
Prof, you are the one that is just teaching us all these things. So well, for me, I can't come across it because I'm just learning all these things newly.
Okay. You see, I came across this site the very first moment 5 years ago, or 6 years ago, when I was introduced to Chemoinformatics. So I began to search on my own. Search, and I stumbled at click to draw. Click to draw is, I don't know who did that, but God will bless those people. What is here? Click to draw contains a comprehensive list of computer-aided draw design softwares, databases, and web services. So these tools have been classified according to the application field. So trying to cover the whole draw design pipelines. So if you think that there's interesting tool is missing in the list, you can also contact them. Now, so what they did here, they entered for databases. Under chemical database, these are chemical database, uncountable.
Wow.
Each of them are under chemical. This is just under chemical database. So when I started, I learned, like, I sat down, I opened each of them one by one. Once you click on it, the link open. Like you can see MBL. Once you open this one, the link will open. So all these are their link. You can access it.
Wow.
So many. I will show you. Just relax. So this is
This is huge.
MBL has opened from that link. I don't know who did this. Swiss, but Swiss are really good. That is from Swiss. So this is under chemical databases. When you still come down, you enter databases handling, voting leader complex databases. Look at all of them. Target databases, pathway databases, chemical structure representation. You will see ChemDraw that we are using, Marvin Sketch, ChemSketch, all that, Data Warriors, some of us have it, and others. If you can take your time to do this drawing online, maybe have the one for app, for mobile phone. I will show you. 3D viewers. This is the Chimera IMO. I use OpenBabel, Discovery Studio, which is also here. So many. You would learn and get tired. Definitions and syntax of the file format. This is for file format. File format converters, OpenBabel, which we use. So we have Corina, we have Indigo. We are just using only OpenBabel. Analysis of ligand protein interaction. So there are two. See where my cursor is. I'm still here. Look at my cursor. Not even up to the middle. Modeling. For modeling, we have Charm, GoMax. So I will encourage you to look at this site because Prof said we can check other database. And I wanted to give this. When was that training? I promised to give. Okay, that was a 1 month training on macrognosy. I told them I would give them this database, so they are going to have access to this. And there are lots. There are lots. Even QSAR tools. So I've just exposed you to something you have to pay for me. So how much will you pay me for this?
Is the goodness of your heart that you are giving us?
Goodness, where?
What
Seriously,
will pay me? Thank you, sir.
our reward is in heaven.
So that is the slogan in Nigeria. When you want to say teachers have their what in the heaven.
Yes, in heaven. Why they will die on earth, but the reward will not be in heaven?
What if the
Well,
person does not reach heaven? One.
I don't know. So I wanted to withhold this information, but for what Prof just said, we need other databases to search and compare. So I have to release it. So by April, if you see what we have for April, the 1 month training we have in April, we are basically learning how to build in that 1 month, how to build the database. This thing we are doing, and then we are crying that is this and that and that. Don't worry. April training is strictly on database development. Build database with simple Excel that can link, that you can link it by maybe once you just type your CID, only the index number, it will bring up everything you need in that data from Excel. So we can just build it in Excel and you can use it for yourself. You can even build it and share it with people. So 1 month, April will be so marvelous.
So
I
I
just
would
give
like to ask
you.
a question.
Yeah, go ahead.
So for instance, these indol analogs were obtained from literature search or literature review.
Yeah.
What can you get the analogs from the PubChem? And if that is
Yes.
the case, can we also use the Campbell that is to build a user modeling in order to find the IC50 of those derivatives of indol either from PubChem or from the literature review. Since it seems that there is difficulty in getting the IC50 from literature review.
Okay. I wouldn't like to build on tracer modeling, because once I'm not doing tracer modeling, it means that my database will not be a depository database. It will be a database of prediction, because any database built on tracer modeling is a predictor database. It will be predicting based on the algorithm. So I want a database that has precision based on laboratory reports. So such that anything you type in that database, if it is not found there, it will tell you no results. But if you look at AdMed Lab, Swiss AdMed, and others, they were built by modeling, by algorithm, with machine learning. PubChem was not built with machine learning. PubChem were built with original data. Lab result.
But service indol derivatives are daily generated. Even you yourself or I myself, I can just look at one structure of it and carry out modeling by generating many of its analogs. So now how do you now take care of the seemingly increasing generation of this indol derivatives?
Yeah, you can self-generate it, but the generation is not the problem. The problem is that do you have the biological data? Do you have, if you generate it, can you synthesize it? And after synthesizing it, can you now do the lab work? Because if you check all those literatures, they generated the the derivatives using their own screen. If you check those literature, they had screen. Then from their screen, they generated their derivative. Then went to the lab and synthesized it. You see the result for their synthesis. So when they now synthesized it, they use each of the products for biological activity test. So we can just generate. We can just generate. Yes, we can generate, but we can't synthesize it, and we may not be able to even we'll not be able to go to the lab. Now I can generate and use already known activity to now predict for the ones I have generated, but it is not reliable because it is not a lab work. So we want a result that if people see it, they can rely on it, because like we know, lab work is the validation, so they can rely on it. That is just, but it's your choice. You can still build a database based on modeling. That one is now prediction. Is prediction. So if you can focus purely on prediction, or you focus purely on original results, but you cannot combine both of them together. All right. Now, but you can use, as we said, you can use PubChem to search for more of the Indo derivatives. Just search Indo. When you search Indo, then you look for bioassay. You just come down to their bioassay. So once you get to bioassay, so from this bioassay now, here has one count. So you can adjust it for active substance count. So active substance count. So you can keep it at active substance. So that you can get those ones that the active substance means that they have a reported lab work. So once is done updating, now look at this. This is active substance, 4,302 Indo derivatives. Yeah, what is that? Is Indo derivatives. So you can open it and let's see. You can open that first one and let's see what is inside. So you can also take these ones and join, because anything in PubChem is not prediction. Anything you get from PubChem is never based on prediction. So while that is opening,
I know.
you know, and
Hello?
you allowed me. Oh my God. Okay. Check the bioassay description if it was really Indo, but I think it should be Indo, still Indo. I can check this one. 3,980 active substance count, which is 4 times with an activity. Okay, good. So let's see their structure down. Okay, data table. Let's see from the data table. All right. Can you find Indo scaffold here? Does this structure look like what has an Indo scaffold? Now, this is where you can also get your experimental work. You can also pick from here to join. This active means that there has a known molecular activity, and the unit of that activity is in a IC50. Let's see. Okay, efficacy, that is EC50. So this is EC50, which is still part of our business. Let me scroll up if I can see. Okay. Okay, so they are activators. Sorry, they are activators. That is efficacy. You can download this, but I'm not sure if this report was done. I'm not sure if this report has well, let me download it first. You can click on download here and choose. Okay, fine. I can find the activity. So just come down, click on download, then choose this active, this data table, the last one, active, less than equal to 1 micromolar. So that is the unit. Then you click on save, and that will save as an SF file in CSV. So you can open it and join them. So we have how many data that we have here? We have 377,000 plus data. So this is, let me help you out. This is the smart code. This is their CID, which we don't need it. Then this is the smart code. So we need the smart code. That is the smart code. You can join the smart code. Please. Inconclusive again. Let me see. PubChem activity outcome inconclusive. They are not sure of this. You need to focus on the ones that are active. Not sure if there is even active here, but they showed us active. Now the active has now become inconclusive. So I won't like to work with this data, this one now, because it's showing me inconclusive. Should have been active. Let me see. Okay. No. So this data cannot go. This data cannot go for me. You go back again. You go back and search again. So you come down. So you keep doing this. You keep doing this. Or instead, you can type Indo IC50. Let's say Indo IC50. So that we can have bioassays purely on IC50. So we can have bioassays just concentrating on IC50. So this is now 5,974. So it has reduced. Active substance count. So you can equally do this. Can equally do this and add it up to your result. Okay, let me open. So this is experimental result, 4,000. I think this was the first one I opened that refused to open. So something really happened to that data. I've not opened this. So you can join PubChem if you don't know how to handle it. You can join PubChem with it. All right, so far wow, this is 10:28. Really want to appreciate you for being around. So we are going to do a mini assignment though. But how many? Okay, let me take instance. In seeing Uncle David.
All right. Thank you, sir. Good evening, everybody. Thank you for the
Yeah.
wonderful teaching and explanation. Though, just as one of my colleagues wrote here, we got lost, but I think the video will really help us to follow up till we become
Yeah.
perfect on it. Sorry, I missed a session yesterday, but I'm concerned about something. I joined a
Okay.
program like this. I joined a program like this either 2 weeks back or last week, something of that
Okay.
nature. And I followed up for the 2 days training. As we are doing some practical, I followed up and did everything. And we were promised that we were going to be sent a mini assignment was going to be sent to us, which we were going to run and submit. I even did a commitment of the 2,000 payments. Since then till now, I've been refreshing, checking the files. How do we call this now? Where the informations and other videos were sent to see if the assignment is dropped there. Up till now, I've not seen anything. No information, nothing. So I don't know.
Okay.
I even wrote a mail. I even wrote a mail to the School of Computational Chemistry and Biology, requesting for clarification, and no reply to the mail till now.
Okay. Your challenge is a minor one. We don't send the assignment to that. We don't send the mini project guide to Drive. We usually send the guide in our WhatsApp platform. So I don't know. We're in the WhatsApp platform for that particular training.
Yes, I'm on a WhatsApp platform. I joined almost all the WhatsApp. I'm on a WhatsApp platform.
If you're on the platform, we drop the guide there. Hey, even the one we did, the last free training we did was on the molecular modeling. The molecular modeling. We dropped the guide, and the defense to that training now is on Saturday.
Sure. So as it is, what am I going to do? I've been following because it is on that very WhatsApp platform that I even saw the flyer for this and register for this very program.
That means probably you stripped it, but all project guideline is always active on the. We usually send it at most 2 days after the end of each training. We'll put up the guideline so that people can see it. So that means I'm going to re-forward it. Yes.
Okay.
So which one exactly is it for Macro 4 or for the molecular modeling?
I don't know actually, but what we did was we got data and cleaning of data, something like that.
Okay. I will just
where we try admin and something.
Okay. Yeah, that is the molecular modeling.
Yes.
That is the molecular modeling. So I will send it. Though the defense is but you got the video, right? You got the video access.
Yeah, I got access to the videos and everything.
Okay, so I will just forward it back to the group. Then you can see what you can do. Tomorrow is Friday. The defense is Saturday, but you can do something on your own. We are giving out certificate of participation to those who wish not to do the mini project. But if you really want to still do the mini project, and since you may not meet up with this time, so we can keep your certificate pending till when you finish the mini project and send to us. Then we'll give you certificate of completion. But if you want to do the mini project, then we can just give you certificate of participation that you participated in the training.
Okay.
All
I
right.
will actually want to do the mini project. Well, let me wait and see if it will be forwarded, as you say.
Yes, I will do that.
Okay, thank you.
So for this,
hello, sir.
Yes.
So I don't think if he is in molecular modeling group, But if you were in molecular modeling group, in those of, I think you should have seen the guidelines, because it's like even today, somebody wrote his name. That is, I think, number 4. For those who are ready to the mini project presentation.
Okay, I will just Uncle David, maybe you
Yes.
can send me a GM.
Okay. I don't know. Can I? Will it be possible I get your contact here?
Okay. Yes. Yes.
His name is on the platform.
My
His number is on the
in any
platform.
of the group you are, any of the group you are, you
Yeah.
check the admin with this logo. Just check the person with this logo, this
Okay.
Hendeb logo, then chat
Yeah.
that number up.
All right. No
Sir,
problem.
sir, you asked us to install Open Babel for this training, but
Yes,
you have not really
yes,
used it.
yes. The reason why we wanted to use Open Babel was mostly for the natural products database, where we have to download them and then convert them to Smile code. They use the Smile code to continue our job. So, but we are not able to look at the natural products database now. We have achieved something, which is basically on the how to build a simple database. Now, your assignment, your mini project is this. You are going to choose any derivative. You're going to choose any derivative. I would just like you to work on at least 5 derivatives. So each derivative will form a sheet. Or is 5 too much? Or 2 derivatives. I don't want something that will stress you. 2 derivatives. 2. So
Derivatives of what?
you can just choose any derivative. Like we use Indo. Mine was Indo and Quinon. So I didn't work on Quinon again. So you can, like, I created sheet 1 for Indo, sheet 2 for Quinon. So you can do the same. You can choose any one of your choice, any derivative of your choice, but don't use Indo again. Use any derivative of your choice. Then, how many derivatives, how many analog per scaffold? Let's say, can you give me 100?
Oh,
So let's say 50 per scaffold. So like for Indo now, you build this for 50. Then for Pinon too, you build the same thing for just 50. I think that is okay. I don't want to bore you with much work. Then make sure you put your index, your index, like index. I can say for this Indo, I can say IND 001. I say IND 002, just like that. So have your index. And also for the Pinon, I can say but the index will be a unique number. It will be a unique number for both of them. And the Pinon will continue from where the Indo stopped. So if you are using IND, so if your Indo stop at 50, so Pinon will start from 51. Now, then create a name for your database. Me now, I can call my own. I can call it whichever name. Just give your database a name. Yes, give your so the file will bear the name of your database. You can say analog. Okay, you can say biological but biological scaffolds database. For me, I can name it biological scaffold database. So you can just create your own database. Who knows that tomorrow you can publish it and people will start paying dollar to access it. So that will be your assignment, just a simple one. As we know, for all our mini projects, our defense for mini project is always 2 weeks after the training. So by next 2 weeks, we shall be coming back for the defense of this particular training. I will still drop the guideline practically step by step usually, so that you can still follow it up and do a nice work. So if you have not registered, if you have not made that the commitment fee of 2,000, I will appreciate so that you get access to. For those who have opened it, we're able to see the wonderful textbook we sent. So wonderful.
I saw some of them.
If you look at those textbooks, they are wonderful. It's for your consumption. You can sit down and read them. They are purely on Chemoinformatics. So we have the library. We have a library of tests in all our training. So for you to read, and read out confusion. So once again, I want to appreciate you for coming around. It's so wonderful. By next week, Wednesday, we shall be having a webinar. We shall be having a webinar by next week, Wednesday. The flyer will be out. And
Hello?
chemistry. Yes.
Hello?
Yes.
Hello? Well done.
Okay, sir. Yes, sir.
Please, I thought you said we should remind you something. I don't know whether you have shown them why the network was bad at my site. So we should remind you that the NMR thing that you want to show us how to do something.
Okay. It's not for this meeting, it's for Saturday. Those that did game draw.
Okay.
Those that did game draw. Those that did the game draw training. So we just show how to generate the NMR spectral data.
This coming Saturday.
Yes, this Saturday is the defense. No. This Saturday is not the defense. Next week Saturday on the 7th. 7th. Next week Saturday is for game draw. Those that did game, the beginners course. The beginners course on the chemistry. That is on the 7th.
I thought it was
so on that day,
on the 7th. Now?
Yes. See, let me clear you. This week Saturday now is for modeling. Yes. The defense for modeling.
All right.
Now, next week Saturday is the defense for beginners course. Next week, 7th.
You know that beginner course you gave 5,000 or something.
Okay.
You told us a month. You gave us a month.
Okay. So sorry. So it will be till then. Now I will show you that game draw. That NMR.
All right.
So sorry.
All right. Okay, sir. God bless.
Because I cannot bring it up here because these people here does not have that game draw and they don't know what we're saying about. All right. This training is still open for registration. That is next week. Green chemistry is open next week from 10th. Is still open for registration. While we conclude the macrognosy, we are concluding that tomorrow will be Friday. The training was so wonderful, and the participant can testify of how it has been since 1 month. At the same time, mastering institutional green chemistry is starting February 10th next week. It will be awesome also. All our training adverts will be available this weekend. The training for second week of February. Then the training for April, for March. We know what we have on March. March is purely on modeling, microfluidic modeling and molecular modeling. So we are merging both of them, and we are giving you full month hands-on training on that. So it will be off.
This thing can be confusing.
You just have to have a date with them. Keep them.
Okay.
Keep them on your calendar. God will still help us. We promise to
Amen.
make it flexible, but there's no response yet from that aspect. Like some of you requested. So once again, I'm glad to have you around. This is almost to 11. It's not easy. So thank you so much for being around. I'll say good night.
Good night, sir. Thank you so much.
Thank you. Thank you. It has been awesome. Yeah, good night.
Thank you, sir.
Good night, sir. Good night, everybody.
Good night.
Yeah, good night.